Hi everyone, thanks for joining us. In this presentation, I'd like to give you a quick overview of our company, Innovative Sensor Technology. Then I'll give a short overview of our thin film flow sensors and how they might be useful in floor care applications. Finally, I'll go a little more in depth about the different sensor variants and how they work. So, a little bit about Innovative Sensor Technology. We're a provider of standard and custom thin and thick film physical, chemical, and biological sensors. We started in Switzerland and we're coming up on our 30th anniversary later this year. Pictured here, we have our headquarters and main factory located in Switzerland's Toggenburg Valley. We have another production facility in the Czech Republic and sales offices located in several countries, including IST USA division in Las Vegas. Across locations, the team totals around 450 people, and we have over 4,000 different sensors and module products, with up to 200 new ones being produced each year. Today, I'll talk about the flow sensors, in particular our FS7, shown on the left. Thin film thermal mass flow sensors have several advantages compared with other flow sensing technologies. First off, they have a small footprint, they're easily adaptable for different applications, they have excellent long-term stability and measurement reproducibility, and the associated signal processing and calibration methods are straightforward. There are a few ways these sensors might be useful for floor care applications. In the case of vacuums, an airflow sensor could be useful to measure performance or perhaps detect blockages, including the need for a filter or bag replacement. Our out-of-liquid flow sensor, shown on the right, could potentially be used for floor cleaning systems, which use water and other fluids during operation. Let's go a little more in depth and see how a gas flow sensor like the FS7 can measure air velocity. The sensor works as a constant temperature anemometer, or CTA for short. It consists of a temperature sensor and a heater located on a single chip. Both elements are platinum resistive meanders, just like what you'd find on a thin film RTD. We specify certain temperature difference between the sensor and the heater. This difference should be constantly maintained at any given flow speed. Just a few notes about the elements. The heater has a nominal resistance of 45 ohms and it heats the surrounding medium through self-heating. The heat is carried away when there's flow in either direction. The temperature sensor has a nominal resistance of 1200 ohms and it measures the temperature of the medium surrounding the chip. Like I mentioned before, we specify a certain temperature difference between the heater and the sensor. For example, let's say it's 30 degrees Celsius. When there is flow, heat is carried away from the heater, and additional power is applied to the heater to rebalance the sensor bridge and maintain the specified temperature difference. This additional power, caused by an output voltage increase, is what we measure. This is then converted to a flow speed. So, how do we interface with the sensor? The FS7 can be operated using a CTA measurement circuit like the one shown here. The circuit compensates for the medium temperature variation using the flow sensor's onboard temperature sensor. The selected temperature difference is set by resistor R3, and resistor R2 should be adjusted within 10% for calibration. You can read more about this example circuit and our recommended 3-point calibration procedure in the FS7 app note on our website. With some other sensing methods, when you're working with fast flow rates, you might need to build another flow channel connected in parallel, then use the differential pressure as a measure of the flow speed. One of the nice benefits of thin film sensors like the FS7 is that we can measure directly in our flow stream, since the sensor can operate over a large flow range. This generally allows for a simpler and potentially less costly design. A couple examples are shown here with our FS2 sensor, which I'll describe a little more on the following slide. If for some reason you'd like to detect both flow velocity and direction, we have another sensor called the FS2. This uses the calorimetric flow principle. It usually consists of a heating element with one temperature sensor on either side of it. Some of IST's calorimetric sensors, like the FS2, contain a third temperature sensor which can be used to measure the ambient temperature, or it can be used to operate the sensor in CTA mode like we do with the FS7. For calorimetric sensors, the heater is supplied with constant voltage or current, or constant power, depending on the sensor model. The self-heating forms a heat cloud around the heating element. With no flow, the heat cloud is symmetrical and both temperature sensors report the same value. But once flow is coming from either direction, some heat is carried away from the heater in the direction of one of the sensors. The resulting temperature difference between the two sensors can be converted to a flow speed and direction. Here I'll just give a quick overview of the available standard elements. First up, we have the FS7, which is our all-rounder suitable for most applications. A few variants are available, including a housed version and a high temperature version usable up to 400 degrees Celsius. Next, the FS2, which is a similar construction to the FS7, but it can be operated in calorimetric, CTA, or combined mode, depending on your application. Like I mentioned before, the calorimetric sensors can tell us the flow direction too. Then we have the microflowsense, or the MFS. The sensing elements are on a thin membrane structure, making it excellent for applications which require fast response times. And lastly, the silicon flow sensor, or SFS. Like the MFS, we get a fast response time. This sensor is particularly useful for applications with low power requirements. Finally, if you're working with liquids like water or chemicals, you might want to take a look at our out-of-liquid, or OOL, flow sensor. Using the same measurement principle as the FS7, this sensor can measure the flow speed of most liquids. Just like the FS7, it consists of a heater and a temperature sensor, and they're soldered on the outside of a stainless steel tube, and there's no actual contact with your fluid flowing through the tube. I mentioned in the beginning that IST not only produces standard sensors, but we also specialize in custom sensor design and fabrication. Common customizations include special housings and assemblies, or custom wire and connector configurations. We can also develop electronics custom tailored to your requirements. Here I show some of our flow sensor evaluation kits, which are available on our website. All right, thank you for your time, and feel free to reach out to us if you have any questions or if you'd like to discuss your floor care application or any other sensing related topics. Thanks, have a good day.